Hello students, in this lecture we will do some questions based on formation of partial differential equation by eliminating arbitrary function. This is question number 9 of exercise 1.2. Obtain the partial differential equation by eliminating the arbitrary functions from the following: z equals to y fx plus x gy. Here in this relation, we have two arbitrary functions fx and gy. We have to eliminate these functions to obtain the partial differential equation. Let this equation be numbered as 1. Differentiating equation 1 partially with respect to x, we have curly z by curly x equals to y. Y is treated as constant, so there is no change in y, into f dash x plus gy is constant, derivative of x is 1. Now, differentiating equation 1 partially with respect to y, we have curly z by curly y equals to fx plus x is constant, x into g dash y. Derivative of gy with respect to y is g dash y. Now, again differentiating equation 2 with respect to x, we have curly to z over curly x square equals to y f double dash x, and gy is constant with respect to x, so its derivative is 0. Now if we differentiate equation 2 with respect to y, we have curly to z over curly y curly x equals to f dash x is constant, so here f dash x into derivative of y is 1 plus derivative of gy with respect to y is g dash y. Now, differentiating equation 3 partially with respect to y, we have curly to z over curly y square equals to derivative of fx is 0 with respect to y, and derivative of this term is x into g double dash y. In this question, we have two arbitrary functions fx and gy. So, we have, for eliminating this, they are not eliminated with the help of three equations 1, 2 and 3. So here we have computed second order derivatives. Now with the help of these we will see that we are able to eliminate fx and gy multiplying equation 2 by x and 3 by y. This is equation 2. Multiply this by x and 3 by y, we have x into curly z by curly x equals to this, and y into curly z by curly y equals to this. Now adding equation 7 and 8, we have x into curly z by x plus y into curly z by y equals to xy f dash x plus x gy plus y fx plus xy g dash y. That is, we can write it as x into curly z by curly x plus y into curly z by curly y equals to, taking xy common from these two terms, we are left with f dash x plus g dash y, and these two terms are xgy plus y fx. Now we have used here equation 5 and 1. From equation 5 we have curly to z over curly y curly x equals to f dash x plus g dash y. So here we have substituted the value of f dash x by z plus z dash y by using 5, and from 1 we can see that this is equals to z. Now this is the partial differential equation free from arbitrary functions fx and gy. Next question. Obtain the partial differential equation by elimination of arbitrary function from the following. From this relation, we have to eliminate arbitrary function. Here we have only one arbitrary function f. The method will be same. First, we differentiate this equation with respect to x. We have curly z by curly x equals to n x n minus 1, second function as it is, plus x n as it is. When we differentiate this function with respect to x, we have f dash y by x into minus y over x square. Now differentiating this equation 1 partially with respect to y, we have curly z by curly y equals to x and f dash y by x, and when we differentiate y by x with respect to y, we have 1 by x here. Now multiplying equation 2 by x and 3 by y, we have x into curly z by curly x equals to n into xn fy by x minus this minus here y into these two powers are x n minus 2, and when we multiply it by x, we are left with x n minus 1 into f dash y by x. Y into curly z by curly y equals to x n minus 1. This is x n, this is x. So this power is x n minus 1. Y we have multiplied here into f dash y by x. Now adding equation 4 and 5, we have x into curly z by curly x plus y into curly z by curly y equals to, these terms will cancel. We are left with only one term, that is n into xn fy by x, and by using 1 we know this value is equal to z. So substituting z in place of this, so this is the partial differential equation of first order free from arbitrary function f. Thank you.